Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of the conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts of preliminary geological investigation fault tunnels in view of civil engineering. So what is meant by tunnel? Tunnel construction requires detailed geological investigation to ensure safety, stability, and economical excavation. So these two terms are listed here with the green tick. Massive rock is there, elastic behavior or stable behavior of rock is seen. At the second, fault zone is there, brachiated zone or unstable rock is there. So geology dictates stability, engineering reacts to geology. Means we have to prefer the tunnel location where the massive rock and stable rock is there. We didn't go for that crack rocks or just like brachiated zone or the fractured rock zones. So engineering geology helps identify rock types, structural discontinuities, groundwater conditions, and weak zones along the tunnel alignment. Geological investigations reduce risk related to the collapse, seepage, excessive deformation, and construction delays. So, selection of tunnel alignment, which is the most important point or the role by the civil engineer, which depends on terrain, topographical characteristics, rock competency, fault zones, and environmental conditions too. Proper geological assessment requires and which improves tunnel design, support system, and long-term structural performances. The transportation, what here the functions are listed: transportation point of view, hydraulic point of view, and utility point of view. So what do you mean by transportation? So tunnels are used for transportation like highway tunnels, railway tunnels, where the risk is there roof fallout from joints due to the cracks or the water seepage. Secondly, hydraulic tunnels for the hydrological activities, just like water tunnels or water conduct, where leakage is there, most important risk via faults. At the end, utility, just like seepage or just like cable or just like gas pipelines, we can provide tunnels where risk is there, urban infrastructure interface. So geological investigation helps engineer to understand subsurface condition before excavation. It identifies unstable rock masses, weathered zones, joints, faults, and groundwater inflow areas. So investigation data is essential for deciding excavation techniques and support requirements based on that transportation activity, hydraulic activity, or utility purposes. Civil engineers use the geological information for safe tunnel alignment and unstable underground construction. The tunnel alignment consideration, which is based on, or we can say that the structural enemies for the selection of tunnel alignment are folding, faulting, and jointing. So structural orientation relative to the tunnel axis determines the hazard level. So if we have to plan the marking the structural alignment for the tunnel alignment should avoid major fault zones, weak strata, and highly fractured rock masses. Alignment selection depends on topographical characteristics, geological characteristics, groundwater conditions, and construction feasibility. So first image where folding planes are there, the yellow color shows that the zigzag plane which is unsymmetrical in the nature. Second image which shows the faulting with reference to the total breccia, or we can say that the combined rock or stable rock, just like basalt. There are so many faults and cracks are there. Also equal and opposite forces are also acting, so that there will be a major damage, or we can say the structural enemy. And at the third image, jointing are there, so there are so many cracks are interconnected and joints are there. So with reference to that, more leakage will be in picture. So the stable rock foundations or stable rock formations minimize support cost and improve the tunnel durability. So we are planning the tunnel for 100 years, so it must be durable. So we have to prevent the structural enemies which are impacting the effect on it. Proper alignment reduces excavation difficulties and which improves operational safety. So what are the surface geological investigation and subsurface geological investigation? Surface geological investigations are on the surface or above the surface, and subsurface geological investigations are below to the earth surface. It may be in the soil layers, it may be in the rock layers, or it may be related to the groundwater activities too. So if we are doing the activity below to the earth surface or just like in the hilly areas, so we can prefer the drill and blast, the flexible response activity, where drilling first and blasting second. So drilling first by using the drillers, or we can say that boomers. We have to charge the explosives in that. After that we have to blast it. After that there will be a huge murk and fumes are in the tunnel. So we have to provide the ventilation for the persons who are working in that premises or in that tunnel. At the same time, ventilation also provides the safety to the workers. We have to use some advanced machines or tools or loaders or muck removers for mucking procedure, and we have to provide scaling and support by using the grouting method or bolting method at the end. So the drilling and blasting, which is a physical and flexible response, are best suited for variable geological conditions just like fault zones or mixed faces or the mixed type of rocky layer, where immediate support adjustment is required at the same time of blasting and drilling. So the subsurface or surface geological investigations include geological mapping, remote sensing, aerial photography, and field observations. Surface mapping helps predict underground geological conditions and structural discontinuities. So remote sensing technique assist in identifying landscape zones and fault controlled terrains during that drilling and blasting procedure. Preliminary surface studies reduce uncertainties before detailed surface exploration. The tunnel boring machine, which is a tool, advanced tool, which is used against the drilling and blasting method. So tunnel boring machine, we can say that TBM, the factory on rails. So TBM itself do the activity of drilling and blasting at the same time with high speed inconsistent rock, vulnerable to the squeezing ground where shield trapping activity is there. At the same time drilling and blasting in picture, so that the drill muck will be collected at the same time and transferred at the end. So cutter head at the front, then shields are provided. Shield supports that cutter head, and gripper pads at the third position, which provide or which absorbs the shocks of drilling, which require massive rock for reaction force. And at the last segment erector is there, where we can use that erector to provide the outer casing. So the subsurface investigations includes drilling, borehole logging, trenching, and geophysical surveys. Core drilling provides information about rock quality, fracture conditions, and groundwater pressure. Geophysical methods such as seismic fraction, seismic activities, electrical resistivity, which detects weak zones. The tunnel excavation method depend on geology, tunnel size, and project requirements. That tunnel is for transportation purpose or water or hydrological purpose or for utility purpose. Drill and blast method is suitable for hard rock conditions, and tunnel and boring machine are effective in uniform and stable geological formations. Soft grout Soft ground tunneling requires special support and ground improvement techniques, where proper excavation methods reduces vibrations, instability, and construction risk also. If we have the rock strength, then it is more easy to construct tunnel. It may be by using the drill and blast method, or it may be by using the tunnel boring techniques. So rock quality determines the stability and support requirements of tunnel excavation. Rock mass rating, rock mass rating, and the Q system are commonly used for tunnel rock classification. The rock classification is based on the sedimentary rock, metamorphic rocks, and igneous rocks on the basis of geological conditions. But we can prefer the strong and intact rocks for the tunneling, which gives hard strata and hard support. Rock classification considers joint spacing, groundwater conditions, and discontinuities orientation. So proper rock mass evaluation improves tunnel stability, analysis, and support design. Here, anchoring effect is there to the overall tunnel from the outward side. So at three part of the tunnel, top heading, bench, and invert. So invert is the bottom part, second middle part is the bench, and operational part is the top heading. So we can use that whole area of tunnel where the external forces are acting on it continuously. We have to control the deformation by using that grouting methods or bolting methods, so that the surrounding rock mass becomes the primary load bearing ring, or that whole ring can sustain the all roads. So we can provide the strength to the rocks. Hazards during tunnel construction. So what are the hazards during tunnel construction? So first picture or first point is water ingress, or we can say that the seepage through the cracks. So permeability is controlled by fractures, not porosity. So in geotechnical engineering, we see that the porosity where soil have tendency to absorb water through the voids, but in the rock there are fractures or faults or leakage, or the spaces available in between the two rock beds, so water is flowing through it. So when we are using the construction activity, or when we are following the construction activity of tunneling, then we have to provide the casing to the whole tunnel, otherwise there may be n number of cracks available through that rock surface, and it may create water ingress hazard. So tunnel protects from the hazards such as by the roof collapse, rock burst, water ingress, and gas emissions. So we have to provide the safety or the casing to the whole tunnel. Weak geological formations increase the possibility of deformation and instability. Seismic activity and fault zones may create additional structural risk. So geological defects such as joints, faults, folds, and shear zones influence tunnel stability. Joint rock masses may create wedge failures during excavation. Fault zone contain crush and weak rock materials that increase collapse risk. So hazard is due to the rocky brittle failure. So what is the condition behind that? Massive hard rock under high confining pressure. Rock stores elastic energy until sudden failure. So here the graphical representation of strain versus differential stress. So stress strain diagram itself shows that the impact of load and the deformation noted. So explosive energy release is explained or marked with respect to the red color through the limestone type of rock, then Wesley granite, then Brescia sandstone, Giorgio marble, Breccia sandstone, Giorgio marble. So there are n number of rocks available. With reference to that rocky surface, we have to mark the stress strain diagram, that which type of rock is most feasible to sustain the stress and strain. So tunnel supports are designed according to rock quality and geological conditions. Common support systems include rock bolts, steel ribs, shotcreting, and concrete lining. Support systems prevent roof collapse and control deformation around the tunnels. The hazard is due to the ductile failure. So hazards, third type of hazard is due to the ductile failure. So ductile behavior, significant strain before failure. So here also the stress strain graph or diagram is there, where ductile behavior is with reference to the red color, then blue color is there, and then green color is there. So three different types of ductile failure occur due to the weak rock or high clay content under pressure. So time dependent plastic flow which shrinks the tunnel diameter. So n number of rocks react with reference to the stress which is occurring on it, and which show the ductile failure, just like shown in the dam, where structure or the structural member may get bent with reference to the external pressure or stress which is acting by the rocks on the structural I section. Summary or the golden rule for the tunneling is that we have to respect the structure, we have to measure the properties of the rocks, and we have to choose the method for tunneling. So respect the structure means faults and faults dictate alignment. So we have to mark or we have to select the alignment based on the various activities we have to perform on site with reference to the availability of rock. Secondly, measure the properties means we have to measure the structural characteristics or the stresses or jointing required for the support method. And third, we have to choose the tunneling method based on that tunnel boring machine or any type of NATM machine for massive rock or drilling blasting, which is more suitable. The geological treatment improves stability and safety of tunnel foundations and surrounding rock. Grouting is a method which is used to reduce permeability and strengthen the fractured rock. Rock bolting reinforce unstable rock blocks around the tunnel openings. Drainage system control groundwater pressure and seepage problems. Proper treatment measures increases tunnel life and reduce maintenance requirements. So the preliminary geological investigation are most important and essential for safe and economical tunnel construction. Understanding the rock patterns, just like based on the strike, deep, apparent deep, properties, structural defects, groundwater conditions, which improves tunnel stability. Geological investigation guides us for alignment selection, excavation methods, and support design. Engineering geology play a major role in minimizing construction hazards through the water, through the stresses, through the strain, through the fractures, and operational risk. Proper planning and investigation ensures the durability and sustainable tunnel infrastructure. So the geometry point of view, strike the horizontal line on a plane, deep maximum angle of inclination which is perpendicular to strike, and apparent deep is the angle in any other direction. Secondly, the classification which is based on the RQD performance, sum of pieces below to greater than 10 centimeter to the total core run, which is exactly dependent on the quality of rocks. Third, mechanics, where brittle nature, sudden failure due to the bursting. Ductile nature, plastic flow due to the squeezing, where confining pressure increases ductility. And fourth one is the faults, net slip, throw, and heave. Net slip, which is the total displacement vector, throw is a vertical component, and the heave is a horizontal component. Stay tuned, guys. Happy learning.